Assalamualaikum and every good day. For 34 DPEX dissertation, presentation and exhibition, we're gonna present our project, and our project title is Study of Eco-Brick Using Seashell Waste as Sustainable Fine Aggregate Replacement. First of all, let me introduce myself first. My name is Zuhaira Nasim binti Muhammad Nazir, and with my partner,
my name is Nurul Ayuni Nabila binti Muhammad Sahari. So, we started with the problem statement. The first one is the continuous use of river sand in a construction has led to serious environmental degradation such as riverbank erosion, habitat loss, and illegal sand mining. This overdependence on natural resources threatens the sustainability of future construction materials by United Nations Environment Programme 2019. Second one is seashell waste generated from seafood industry is often discarded into landfills or coastal areas, contributing to environmental pollution and waste disposal challenge. Improper management of this waste not only affects marine ecosystem but also increase landfill loads. Sultana et al. 2021.
we move to our project. First, to produce eco-brick using crushed seashell as a partial replacement for fine aggregate. After that, to evaluate the compressive strength of eco-bricks containing seashell waste, and then to determine the water absorption of the rate. Lastly, the size of brick that we use for our project is 250 mm times 103 mm times 33 mm.
So now, I will explain the procedure for producing our eco-bricks. So for the first step, we started by crushing the seashells into fine particles and seizing them to achieve a uniform size similar to fine sand around 2 mm or smaller. So this step is important to ensure that the crushed seashells can blend well with the cement and sand. So next, we prepared all the materials according to the design mix proportions, and then the mixture was poured into mold and left for a few minutes before carefully lifting the mold. So once the bricks were formed, they were left overnight before being placed in the curing tank for water curing. This curing process helps to improve the strength and durability of the bricks. And then after the curing period, the bricks were removed and tested for water absorption to evaluate their performance.
And then, all the brick sample is placed in the compression testing machine. The machine applies load and shows the reading on the screen. After that, the brick breaks when it reaches the maximum load. The test results are recorded and documented. And lastly, the data is analyzed to determine the compressive strength.
For this slide, I will be explaining the mix proportion that we use in producing our eco-bricks. First, for the cement to sand ratio, we use 1:5, which means 1 part cement and 5 part sands. This ratio is commonly used in cement brick production because it provides a good balance between strength and workability, making the mixture easier to handle and mold. So next, for the water cement ratio, we keep it at 0.55. So this value is important because too much water can weaken the brick and cause cracking, while too little water can make the mix too dry and hard to work with. So 0.55 ensures proper mixing and consistent quality for all samples. Then, for the seashell replacement levels, we replace sand with seashell powder at 0%, 5%, 50% and also 20% by weight. This was done to find out which percentage give the best results in terms of compressive strength and water absorption. So lastly, all our brick samples were cast using standard mold size of 250 mm times 103 mm and times 63 mm. So this helps to make sure that every brick is uniform in size and that our testing results are accurate and reliable.
Let me explain about testing method, which is compressive strength and water absorption. For compressive strength test was to determine the maximum load the eco-brick withstand before failure. Moreover, conducted after 7 days and 28 days of curing using compression testing machine, which is called CTM, indicates the brick's structural strength and performance. For water absorption, is to measure the amount of the water absorbed by the brick after being immersed for 24 hours. helps to evaluate porosity and durability of the eco-bricks, lower absorption, better density and quality of the brick.
For our solution, we focus on using crushed seashell waste as a partial replacement for fine sand in the production of cement bricks, which we call eco-bricks. Let's take a look at this short video.
For proven effectiveness through testing, look at the graph that shows the 15% seashell replacement show the highest compressive strength, proving it is the most effective and optimal mix for eco-bricks.
Next, this graph shows the water absorption results for different seashell replacement levels. We can see that the absorption rate slightly increased from 5% to 15% and then decreased again at 20%. The 15 seashell mix maintains acceptable water absorption levels, making it the best balance between strength and durability. This means that at 15%, the brick is not only strong, but it also resists water absorption effectively, which is ideal for construction use.
Let's talk about innovation impact. First, environmental sustainability is reduced dependence on river sand, minimizing illegal sand mining activity and supporting green construction practice. For water reduction is recycled seashell waste from the seafood industry, helping to reduce landfill disposal and coastal pollution. Moreover, support for sustainable development is contribute to the Sustainable Development Goals, SDG 12, responsible consumption and production, and SDG 14, life below water. Lastly, encouragement for research and education is provide opportunities for civil engineering students and research to explore sustainable building materials, green innovation.
Fourthly is the cost efficiency. By replacing part of the fine sand with crushed seashell powder, we can lower the cost of construction materials since seashell waste is easily available and doesn't need expensive processing. And lastly is material performance improvement. The seashell powder helps to enhance the compressive strength and the density of the bricks through what we call the filler effect. This means the tiny particles of seashell fill in the small gaps in the mix, making the brick denser and stronger. In conclusion, the study proved that crushed seashell can be used as a partial replacement for fine sand in eco-brick production. The best result was achieved at a 15 replacement level, which provide the ideal balance between strength and water absorption. Overall, this innovation supports sustainable construction by minimizing the use of natural sand and promoting marine waste recycling. Thank you.